On Earth, fire is a familiar sight. We see it in our fireplaces, on our stovetops, and even in the flickering flames of a candle. One thing all these fires have in common is their upward dance. The flames rise, reaching towards the sky as if drawn by an invisible force. This familiar behavior of fire is so ingrained in our minds that it's hard to imagine it behaving any other way. We light a match, and the flame always points up. This upward movement of flames is due to a fundamental force we experience every day: gravity. It's the same force that keeps us grounded and makes objects fall to the earth. But how does gravity affect something as seemingly intangible as fire? Gravity plays a crucial role in shaping the flames we see on Earth. When a fire burns, it heats the surrounding air, causing it to expand. This hot air, being less dense than the cooler air around it, rises due to buoyancy. As the hot air rises, it draws in fresh oxygen from the surroundings, which is essential for the combustion process to continue. This continuous upward movement of hot air and the influx of oxygen give the flame its characteristic elongated shape, always pointing towards the sky. Imagine a hot air balloon. The burner heats the air inside the balloon, making it less dense than the surrounding air. This difference in density causes the balloon to rise, defying gravity. In the weightlessness of space, fire behaves very differently. Without gravity to dictate the upward movement of hot air, flames don't rise in the way we are used to. Instead, they take on a fascinating form, a sphere. Imagine a drop of water floating in space. Without gravity to pull it down, it forms a perfect sphere due to surface tension. Similarly, in the microgravity environment of space, flames burn in all directions equally, resulting in a spherical shape. This spherical shape allows the flame to consume fuel evenly from all sides, creating a mesmerizing display of combustion. To study this unique behavior of fire in space, scientists have conducted numerous experiments aboard orbiting laboratories like the International Space Station. These experiments involve igniting small controlled fires within specialized chambers to observe how they burn, spread, and extinguish in microgravity. The findings from these experiments are not only visually captivating, but also crucial for understanding fire safety in space. These experiments have revealed that fire in space can be more hazardous than on Earth. Since the flames burn hotter and longer in the absence of gravity-driven convection, they pose a greater risk to astronauts and equipment.